Hello, everyone. A very good morning, afternoon, and evening to all. Dear authors and invited guests, welcome to Technical Session 5D. My name is Anisha, and I would be moderating this session. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the Third World Conference on Information Systems for Business Management, ISBM 2024, Bangkok, Thailand. The third edition of the conference is being organized in a hybrid mode. The physical event is organized today in Bangkok, Thailand, and the virtual event is being held through Zoom today and tomorrow, that is 12th and 13th of September 2024. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations, and each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. And on 10 minutes, I'll be raising a gentle reminder. There's another request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, you can write it to me in the chat box. So just before we start the session, I'd like to introduce you all to the chair for this session, Dr. Paras Kothari. Dr. Paras Kothari is a professor and head at Gitanjali Institute of Technical Studies, Udaipur, India, an experienced head of training with a demonstrated history of working in the professional training and coaching industry. Skilled in PHP, database, mobile applications, Windows Communication Foundation, and Android development. Sir, I welcome you to the session.
Hello, am I audible? Thank you.
Yes, you're audible.
Thank you, Anisha. Thank you very much.
Sure. So now we'll be beginning with the session, and we have our first presenter, Mithil Bhavishi, with the paper title, A Synergistic Approach to Analysis of Variance in OA Problem Solving Using Machine Learning. So, Mithil, if you're here, you can start with your presentation.
Yes. Am I audible?
Yes, you're audible.
So it's fine, right? I'll share my screen.
Sure.
All right, thank you. So first of all, a very good morning to one and all present here. Today I'll be presenting a paper which is titled A Synergistic Approach to Analysis of Variance, which is also known as ANOVA, Problem Solving Using Machine Learning. Moving ahead with the slides, we'll start with the abstract. So basically, one must know what ANOVA is. So ANOVA is a statistical test that is used for comparing group-wise means. So basically, when we have a table data given in a tabular format with different types and different people in it, in that case, we can use either F-test or T-test, or when we have more than 3 columns, we shall resort to using ANOVA for the statistical analysis. The main challenges that we faced while solving ANOVA problems was the complexity that the data can become very huge and very complex, which while solving manually takes us a lot of time. And the second is the interpretation. So there can be many types of ANOVA problems. There can be one-way, two-way, and those are further divided into various steps in which we can solve them, which are known as completely random design, random block design, or two-way ANOVA. So basically focusing on these challenges that we faced while our education also, we have decided that a novel approach must be needed that can be used to solve these problems, which will also make it easier for students to understand how to go ahead with this. So moving on, here's just a small introduction about ANOVA and how it is very popularly used in various fields like medical, social science, agriculture, and more. Mainly, ANOVA is used because of its high accuracy and good interpretable results. So our paper aims to overcome the challenges that I have mentioned before and make it easier for everyone to understand and solve the problems without getting deep into the workings and understanding of how one should go ahead. Next, we have performed some literature survey for the same. In this, there was no previous approach that solved the ANOVA problem. So we had to resort to using some papers which showed us how the ANOVA problems are solved manually, what are the steps in it, and resorted to other papers who have used other statistical models like F-test and T-test and used machine learning models in order to train the data set and give a feasible outcome for this. Moving on, our proposed methodology, since it is a machine learning based model, of course, we had to curate a new data set. So to create the data set, we have used various textbooks and PDFs that were available online in order to get example ANOVA questions. Once we had that, we had to figure out manually what type of ANOVA questions were there. Were they CRD, were they RBD, or were they two-way ANOVA? Next, we also had to figure out the alpha value from the given question, since it is a important characteristic of each question that is used in calculating the F-test values for ANOVA. So once we have all the data set, we need to do a little bit of pre-processing, figure out the tables, how they are given. Sometimes the data format is wrong. Sometimes the number of rows in the tables are incorrectly given. So moving on, we had to clean those data manually and create a data set on which we would train our ML models. So for models, we tried out various approaches like logistic regression, decision tree, SVM, and more. But on calculating the precision score and the accuracy, we found out that SVM was the best suited for this approach due to its high accuracy, which would be around 95%. Next, we will, when the user uses this model, they just need to enter the question and the table of data that the question already has, and the model will automatically detect what type of ANOVA it is, what is the alpha value of the ANOVA, and automatically also solve the ANOVA in a way that the user is. I'm sorry, I guess someone was speaking. No worries. Yes. So moving on to some of our results. As you can see, we have compared all the three types of ANOVA, that is CRD, RBD, and FD. The precision and the F1 score are given in the table, whereas the SVM consistently scores higher values when compared to different other models, and logistic regression is somewhat the worst out of all the four. So moving on, here is an example that we found from a textbook, which is basically an example of a random block design. We as humans can figure it out since we can see that there are five different types of supplier and three different types of speed. But to a model or to any Panda Python program, this is just the pandas are a data frame. So we had to figure out with the help of models how we can divide the outliers, that is the supply and the speed. And then once we have figured that out, if there are many types of supply and many types of speed, then only we can conclude that it is a random block design. The question usually does not have any interpretation that we have to use ANOVA or which type of ANOVA. We also have to figure out that in some edge cases where there are less than three columns, using the ANOVA statistical model is a worse option when compared to using t-tests or f-tests. So all of those edge cases are also covered in our project. And the question usually gives us an alpha value like given in last of 0.01 or 1% variance. But sometimes when it is not given, we also have to consider the 5% value as the default option. All of this is derived by our machine learning models. No kind of regex or text reading is being done here. So as you can see, this is the same question that we have solved, where alpha is given accurately predicted as 0.01, and the type of ANOVA for our data is found out to be RBD, which stands for random block design. Next, we have eliminated all the extra columns that are not needed and only focused on the data value, the values that are needed. Then going on with the steps of ANOVA, we need to find the global mean. So for each of the columns, we have found out a mean and shown it to the user. And finally, we also show the overall mean, that is the mean of every data value present in our table. Finally, we create a SS table, which consists of treatments, blocks, and errors. This table varies for each form of ANOVA. For example, completely random design will not have the blocks row, and FD will have another more rows present in it. So once we find out the sum of squares, which is the SS columns for treatments, blocks, and errors, we also need to find out the degrees of freedom for the same. The ANOVA has a unique formula for each of these. Like the degrees of freedom is for treatments is considered to be the number of columns minus one, while for blocks it is the total number of rows minus one, and so on. Once we find that out, we can divide the sum of squares and the degrees of freedom to find out the mean square, the MS columns. And from the MS columns, we can then find out the F values for treatments and blocks. Once we have that, we can compare it with the F critical values that we can calculate using the F table. So in this case, our F calculated comes out to be 12 and 2 for treatments and blocks respectively, while the critical values come out to be 8.6 and 7 using alpha 0.01. Since our calculated values are greater than the critical values for treatment, we have to reject the null hypothesis. And for blocks, our F value is less than what the critical value is. Thus, we accept the null hypothesis. These are assumptions that we already make before solving the ANOVA problem, that if the F test is greater for the calculated than the critical, then we reject the null hypothesis for the same. And if it is lesser, then we accept the null hypothesis. Moving on, concluding our presentation. So the results show that the SVM model has the highest accuracy, and thus we have chosen to use that only. Next, our model accurately finds out the type of ANOVA, that is CRD, RPD, and FV, and also solves it in a way like a normal human would solve, giving each step in the process. So it becomes easier for someone who wants to understand ANOVAs also, that how they should proceed with it. This approach usually simplifies the ANOVA solving process, making it easier for students and beginners to just put in the question and figure out how they will go ahead solving the problems. Next, our future scope would include expansion to other types such as MANOVA and ANCOVA. Those are more complex than ANOVA, which we can easily implement once we include those data in our data set. We could also use optical character recognition, which would enable the user to just click a picture of the problem and the table, while our OCR model would recognize what the values are and pass it to the ML model. This would make it much more easier to use and improve the effectiveness of our model as well. So that's about it from my side. Thank you everyone for listening, and we shall move to the questionnaire if it's fine.
Thank you, Mithil. Do we have any question from the other presenters or audience? Okay, Mithil, I'm having one or two small questions just to check that. What is the synergetic
Yes.
approach you used while you are implementing the ANOVA in context of machine learning?
Yes. I'm sorry, could you repeat the starting? A synergistic question approach was your question.
As test, that a synergetic approach to analysis of variance means ANOVA problems using learning. So, what is? Can you explain synergetic approach?
By synergistic, we were trying to imply that this is a one-stop
Are you getting
solution.
my?
Yeah, I'm getting your point.
Oh,
That you are asking about the synergistic approach that we are using, right?
right.
Yeah, so by that, we actually were trying to imply that this is a one-stop solution for everyone. One just needs to upload the question and table, and he'll get all the steps and all the reasoning behind the steps. So it synergizes everything into one portal where the user can just find out everything that he needs to.
And can we process? Can we use the same process with any other statistical method or statistical approach?
Yes, sir, that was in our future scope, like I mentioned previously, like Manova and Ankova. Using the same
ANOVA and
model, we
ANCOVA, that
can,
is the extension of ANOVA.
yes, we can also try out using t-tests and f-tests.
Okay. And the one more final, what are the basic limitations of two-way ANOVA in context of machine learning?
In context of machine learning, the main
The
limitation,
limitation of two-way.
yeah, for two-way ANOVA, main limitation is the type of table. So here in the question, as you can see, the table has no vertical lines. So it becomes a hassle to understand all the different types of tables and also figure out the outliers. That is, in this case, the supply is not a part of data. It is a part of the question that shows that there are 5 different blocks of supply. So in two-way ANOVA also the same problem applies, figuring out what part of the table are used as blocks and what part is used as a data set.
Okay. And suppose if the data type is image, in that case, how we will handle it?
We actually had tried out using popular OCR models available like Tesseract and Google Vision, but they were not accurately able to understand how the tables work. Like in this case, even if the picture is of a good quality, we were getting wrong data outputs from OCR. So we actually
So,
put it as a future scope.
so that may be the limitation at this point. It may be
Yes,
in
yes,
future we can proceed with that.
yes.
Okay, thank you, Mithun. Thank you from my side. All the best.
All
Good
right.
luck.
Thanks a lot. Thanks a lot for asking.
Thank you so much for the presentation. Now moving on to the next presenter, we have Mohammed Alam with the paper title AI-driven solutions for regression testing, insights from Bangladesh software industry. So if you're here, you can start with your presentation.
Yes, I am presenting here, so I want to share my screen.
Yeah, you can.
So can you see my screen, and am I audible with all?
Yes, you are there.
Yes.
Okay. So thank you everyone to give me the opportunity to present my paper here in the ISBM 2024. So my paper title is that AI-driven solution for regression testing, insight from Bangladesh software industries. Paper ID 300. So the papers explore the regression testing challenges in Bangladesh random 10 software firms and papers of AI-driven solution. So table of contents, basically the introduction, problem statement, methodology, result, proposition, and conclusion. Basically, I will go first because the time is limited. Okay, so the introduction is basically provide an overview of research topics, objectives, significance of the papers. Problem statement, discuss the details, problem, regression testing in Bangladesh software industry. Methodology, basically the data collection and design process. Result, actually the key findings and key issues to solve. Proposed suggestions, basically finding suggestion for the AI test and tools for the Bangladesh industries. And conclusion, summarize the key findings and the proper future aspects of this solution. So this is the introduction. Let us introduction. So what is basically the regression testing? So regression testing is a type of software testing that ensure that the changes of update of software systems such as bug fixing or new features included into the new system. So it is basically the critical and maintaining software scalability, stability, and the reliability, especially improvement of with the frequent update or changes. So context, software company in Bangladesh face challenges with the regression testing tools due to dynamic systems and update regularly. So time constraints, limited resource, manual testing, error findings, and reduced coverage, the lack of systematic framework for test case ranking hampers efficiency. So the objectives, this paper explores regression testing challenging in Bangladesh in random 10 software firms and propose AI-driven solution for the industry. So the purpose, the research provide an in-depth explanation of the characteristics that set small software companies in Bangladesh apart, highlighting their strength and adaptability strategies. So where our contribution is, we examine the total system in a way that testing and support by insight from the real world example and a summary of relevant research. The subsequent sections offer research-driven perspective, dealing the issues, proposing a solution for our industry. So in the section 2, we will start with the problem statement. What basically the problem in our industry? So nature of the problem. Regression testing is a vital component of software coordinations for software companies in Bangladesh, but it also represents a number of different kind of issues. These software companies' environments are characterized by constantly changing math and complex system in interconnected parts, which makes the difficulty of identify the areas that impact by the regression testing in software. So challenges faced by the company, the Bangladeshi 10 software companies has participated in this in our survey, and we basically try to find out the key aspects of the challenges. So the challenge includes main four key points. We basically focus on this paper, that is resource constraints, testing complexity, rapid development cycles, and test data management. So first of all, the resource constraints. The many software companies in Bangladesh, in terms of skilled personnel, time and budget for the regression testing process, and some of our interviewers share with us that the time and resource needed in regression testings and a huge, so they do not do that. Basically, they don't have the resource to do the regression testings. Then the testing complexity. This complexity of modern software applications pose and challenges the maintain complexity testing coverage during regression testing. Basically, here we face the problem with the boundary value analysis, because they cannot, as they have the resource limitations, so they cannot cover the total boundary of testing. And the rapid development cycle. The first phase development cycle is the software industry make it challenging, conduct thorough and timely regression testings. And there is also a dedicated team in most of the firms for testing, and they cannot do proper testing. So here is a big problem in the industry, that most of the companies do not have the dedicated software testing team, so they cannot test individual of the software. The development team is basically testing the software. So there is a huge error is happening here in the time. So test data management, effective management of test data, especially in large-scale project, in significant challenge faced by the software firms. Also, the deadline of the projects are too small, so that they do not have the work to full test. So this is one of the main challenge of the industry, that they have a limited time from the stakeholders. So in the client, for the customer side, they do not have that much time to give the product early delivered. So most of the time, the time is very limited. So that's why they cannot test for full cycle. So method, we will discuss very shortly the methods. Basically, we designed the research adopting mixed method approach. This study combines quantitative and qualitative data collection methods and so holistic understanding of subject matter. Qualitative data is gathered through structured service, and the questionnaires distributed to the different companies with the different role. Basically, the role including tester, project manager, software engineer, software quality assurance engineer, system analyst, and the business executive. So data is collected basically in different ways, like business and Bangladesh software companies, random 10 companies, basically we are surveyed in the different stakeholders. The survey encompassed over 10 companies, and which is basically small and medium. So finally, section 4, we'll go for the result. Basically result, and we see a data analysis here. So complexity of the regression testing. So if I start with the first one, the difficulties of identification issues, resistance to change. Then the second category, development challenges, rapid development cycle, test data management. The third category, we can find out that the lack of systematic issues, frequent adjustment in no test case used. And the fourth is the strict time constraint, resource constraints, limited testing resource. Fifth is overall quality, impact quality. And the sixth is dynamic software testing complexity in quiet system. Error and poor coverage, which I discussed already, manual testing issues, and human fallibility. So this is basically, we found from the result that complexity of regression testing is part of the software industry. So what should be the proposed suggestion for the industry? Next section, section 5. So the proposed suggestions, we do a model for proposed suggestion for our industry. First of all, the integrating AI power testing tools like machine learning algorithm. We can use automated testing generated, identification of critical test cases, prediction of potential defects, automation of repetitive testing tasks. So second, benefit of automation, so time saving for testers, improve testing efficiency. Then recommendation for the companies in Bangladesh, invest in automated tools and techniques, improve test effectiveness. challenge and solutions. So improved software testing professionals ensure high quality software meet intent functionalities, support software testers. Implementing AI-driven testing framework, which is very important for industry, tailored to specific needs and Bangladesh software firms, reduce times and effort in regression testing, streamline testing process, increase test coverage, and finally, enhance overall software quality. So this is basically the mind map for the proposed solution. So suggested tools from our research, we suggest that the test team leverage machine learning to create stable and maintainable automated testings. So Mabel, this is basically a machine learning tools to automate, identify issues in web applications during regression testing, which is focused on continuous integration and continuous delivery. Apply tool, so use AI to automate visual testings, ensure that the user interface remains constant across the different speeds and platforms. And finally, the Selenium-based AI frameworks, for example, Selenium, enhance traditional Selenium with AI features like self-heading test automations. So in section 5, we will conclude with our conclusions. So basically, we discussed the key finding. First of all, the study has underscored the resource constant testing complexity, rapid development cycle, test data management as a significant handle of encounter of software developments in Bangladesh. These challenges have been identified as implemented to deliver high-quality software within estimated times and budget, with of course, the customer satisfaction also. So motivation, embracing AI for regression testing comprises a strategic move toward achieving sustained growth and excellence in software development in Bangladesh. The conclusion in the survey has not highlighted the challenge faced by the Bangladesh software firm in regression testings, but has also provided a clean path forward through the adoption of AI-driven solutions, offering a transformative digital transformation of Bangladesh and limitation of industry in traditional regression testing methodologies. So finally, definitely there is some limitations in our surveys and the research. The limitation of the survey may emphasize a list of limited of scope, potentially restricting the generalization of the finding beyond Bangladesh software firms. Additionally, response bias could be influence the result of participating firm may not fully represent the entire spectrum of challenges and the entire process of what they are doing actually, basically, opportunist integration testing. So in summary, what you can say from our research, the suggested approach of the incorporating artificial intelligence into regression testings has proven to be a game changer, providing an efficient way to tackle the existing challenge. By utilizing AI-driven tools, including machine learning algorithms and automated test generations, companies can prioritize key test cases, analyze the test cases, then compromise the test cases, and anticipate possible defects and automate repetitive testing process. This leads to increased testing efficiency and improved software quality, and the quality and continuous improvement will be better. Additionally, the adoption of AI in regression testings hold significant promise of driving innovation, speed up the product release cycles, and overall product software quality. So that's all from my side, from my research presentation. So if you have any questions, then I can ready to ask and answer the questions. Thank you, all of you. Any questions from anyone?
Okay. It was good to listen to you, Mahbub, on the software testing, especially for 10 companies of Bangladesh. You mentioned one line in your presentation that he did not cover total boundaries of testing.
Which sections?
Can you point out those boundaries?
Oh yeah,
maybe in the description.
Yeah, basically.
While you were doing the testing of regression.
Yeah, I understand. Basically, we basically did a survey for the 10 companies in Bangladesh. Basically, they are very small and medium companies, not the large companies. So basically, we focus on the small and medium companies that they are basically facing a lot of struggle for testing the software. And that's why low quality software is going to the customer side. So what we get from our research that they cannot cover all the boundary. For example, if you know that boundary value analysis is not covered by most of the companies because of the lack of resource and lack of time, because the customers want very early, because maybe the software development need 1 month, but they are asking for 15 days or 20 days. So in that cases, that they quickly deliver the product, and that time in the development side, they cannot do the regression testings. But when it goes to the UAT or user acceptance testings, that time that problems arise. So that's basically the
So means
in our country of the local companies.
so okay. So means your test companies, 10 test companies you considered, those
Right,
were
exactly.
on manual testing
Yes, definitely. The maximum company in small
or
and
using.
medium, they're doing the manual testings, and that's why the problem is that in the manual testings, most of the times they cannot cover all the test cases, and some of the companies basically they don't have the test cases also. So what basically they have to test that actually don't know. So from the development side, developer basically doing the testing. So that's the issue basically. And most of
Can
the
you
companies
generalize this?
they don't have the dedicated test team for doing the software test.
So can you generalize your solutions to the other countries also for the medium and small software companies?
Yes, the summarize, as we already suggest some tools like test team, Mabel, and like some AI tools which is very popular nowadays. That can be used in the testing phases, and definitely that should be an improvement rather than the manual testing.
So okay, so means you want to say that these problems which you are facing in the 10 Bangladeshi companies, maybe in other small and medium level of software companies of other countries also.
Right, but the problem is there is some budget limitation, because these tools are very sometimes very expensive for them. So I just suggest them, but I don't know they have capable to capable to do this.
Okay, good. Okay, thank you. All the best, now.
Okay, thank you, Parash. So
Thank
do
you
you
so
have
much
any
for
other
the
question from anyone?
presentation.
I think no questions. Thank you.
Yeah.
Thank you very much for giving me the nice opportunity. Thank you, Anisha, also. So give me the opportunity to present my research. I hope.
Yeah, most welcome, sir. Yeah. So we'll be moving forward to the next presentation now. And next up we have Sherapon Kietmani with the paper title Curriculum Learning for Assessing Thyroid Nodules Using Imbalanced Ultrasound Images.
Good afternoon, everyone.
Yes, you may start with your
sharing
presentation.
slides.
Sure.
Thank you, you guys, for having me here. I'm a lecturer at the Department of Computer Science, Ramkhamhaeng University, Bangkok, Thailand. Today, I would like to present the curriculum learning for assessing thyroid nodules using imbalanced ultrasound images. Let's say the effective of the well-known method for screening. Basically, we use ultrasound images for diagnosing thyroid nodules. And then we would like to create the deep learning model to distinguish between benign and malignant nodules. General, in medical image processing, we know that the data we obtain, we have the number of negative sample very much greater than the number of negative sample, similar to the cancer nodule that we could find in our data set, less than the number of benign nodules. And we have observed that the general random data augmentation can introduce noise and could distort the critical features that used for diagnostics the nodule. For example, the blue color showing the thyroid nodule in the center, you could see that you can see that it's quite difficult for the sound wave to pass through the nodule because the nodule is thin and hard. That's why you could see this part like this. It represents as the hard part would be cancerous nodules. If we perform the vertical flip or high degree of rotation, it means that it's illegal. How to say, irregular pattern to distinguish the nodules. So we avoid this kind of general transformation. Our research, then we would like to improve the deep learning model that sometimes suffer with imbalanced data set and the normal transformation as I showed before. Therefore, we utilize the weekly supervised data augmentation network that I will call WSDAN from now, and the curriculum learning. See what the difference that WSDAN perform. While training, there are two mechanisms to generate the data augmentation that specific to the feature that would be like would show attention or would be considered by the model to learn the pattern and classify either benign or malignant nodules. There are two mechanisms. The first one is attention crop and attention drop. That you can see that the figure C showing the input image and from the feature attention mechanism in the yellow dash box, you could see this is the high attention area. So it's cut only this part and resize and feed to the model while training as augmented data, similar to the dropping mechanism for model generalization. We also use the attention map, and then we drop the mode attention part to see what is going on if the model didn't learn this part, some kind like this. Not only the good mechanism for deep learning, we develop the curriculum schematic based on curriculum learning that inspired by human learning, that people can learn from simple thing and then start the number of difficulty harder and harder, kind like that. There are 4 stages that we design, starting from very easy, hard, and very hard. This one represents the example of our data set that you could see that the first row represent for very easy, and then gradually add the difficulty to the last row that very hard. The first 2 columns represent the thyroid nodule that benign. The last 2 columns represent the malignant nodules. From the first row, you could see like it's quite easy to differentiate between benign nodules and malignant. And the last row, you could see that it's quite difficult for us to distinguish which one would be benign or which one would be malignant, some kind like this. The stage 0 that normally in deep learning model that we use all the data set to train the model. While training, we call that one the single stage, that we do not separate the data set. However, in our purpose, we try to schematic. The first one, we train on top of the WSDAN deep learning model with the very easy image first. And later on, we get the best image. And then we train on top again and again 4 times. And then we use the final weight for our evaluation. Different to the schematic tool, we train on top, but we use the previous data set too. It means like the model chance to repeatedly learn the previous stage combined with the current stage. And we gradually train and we got the final weight for our evaluation. This is overall the diagram from this purpose. We generate the curriculum learning schematics for our deep learning model. We recite our images and then we feed to the deep learning model, and then it could attract the feature extraction from the feature extraction map. We random select 2 feature maps, one used for attention crop and another one used for attention dropping. And finally, they learned. You could see like from the generating, this one is like insight augmentation too, for making the model learn the important part in the images, and then also drop some parts and it could learn. Finally, we got the 2 classes, like either benign or malignant. We use imbalance data wire training that we obtained 400 for benign nodules, 200 for malignant nodules. And we decided that we make the dataset for validation and testing as the balanced dataset to evaluate wire training, and after the model have trained. Our result, you can see from the table, we use precision, recall, F1 score, and accuracy as evaluation metrics. We have 3 different experiments. The first one that we use for the data set normally as the process to train the machine learning like this. We call this one the single state. And then we separate our data set into state 1, state 2, state 3, and state 4. Start from very easy to very hard for both benign and malignant nodules. From the result, the model improved the performance, especially for the schematic tool. That model have chance to learn dataset more than 1 times. And from the experiment, we could see that in each state, the best weight have updated its weight for adapting the learning pattern to according to the each state of the dataset that we provide. Finally, from our experiment, we could say that combined WSDAN and curriculum learning could improve the ability of classifying the binary classification. And the curriculum learning allow the model to build better understanding by gradually introduce the harder examples. Overall accuracy is improved compared to the single stage. Our future work, we plan to experiment more about how to separate the stage, either like add the number of state or reduce the number of state, some kind like that. Thank you very much for your attention.
Okay, thank you, Dr. Chettapon. Is somebody having any question?
Yes, I have one question regarding this research. So I have a question with the Chandrapan. So do you have any request on this area that early age, how can we detect this type of thyroid problem in your research?
Let's say in general to cancer disease, the early detect is it could be like early diagnosis, early treatment, then it's like maybe avoid of being dead or lifelong expansion.
Like, for example, if I tell that in terms of Bangladesh, because very almost 50% of the female like age 30 crossing 30, they are basically the problem of thyroid, and their thyroid ratio will be increased by day. So do you have any suggestions about that early detection of this thyroid for the female?
Let me explain in the thyroid. In thyroid in Thailand clinical screening principle. Let's say like if you could not like palpation with your part of thyroid and you could not see any noticeable, and then it's recommend like women or man who age greater than 60 years old should go to the hospital or clinic to examine their thyroid part, and with screening with ultrasound first, because it's a non-radiation technique and is not expensive.
Okay. So your suggestion is go to the doctor and check the body, right?
Yeah, if you could not find yourself by palpation to the part of thyroid, or you don't have a symptom like very weakness or your weight change dramatically, something like that.
Yeah, right. I'm basically asking for the symptom, in any kind of symptoms, so that I can early detect the problem and I can go for the treatment.
Yeah, as I know, the basic symptom for people who suffer with thyroid, you could see like you could how to say observe your behavior about like fatigue, weight, right? And the if like your weight change very change the how to say dramatically, like you could notice the difference that's not normal, or like you feel very fatigued, tired, although like you continue your regular basis, your routine. That would be
okay. Oh, I can understand. That means you are telling that a good lifestyle is necessary, right? And the restlessness, the sound sleep is also there needed, right? Okay, I basically
I'm because I'm not a doctor in I'm not
okay,
a radiologist
I understand
in
your issue.
part two, but like my research is focused on medical image processing. So I think as far as I have the basic of the thyroid disease, sorry that I could not.
No issue.
go to
Chandpal, I'm
deeper
just
detail.
asking because I have the inquiry in my mind. That's why I'm asking. Okay. Thank you for, because this is the topics related to this one, that's why. Thank you. Thank you very much.
Thank you very much for your question.
Oh, thank you, Dr. Tengupar. Over to Anisha.
Okay, sir. So thank you so much for the presentation. Moving on to the next presentation, we have Katha Chaudhary with the paper title Detection Model for Fake News in Bengali Language Using SVM and Random Forest. So, Ma'am Katha, you may start with your presentation now.
Okay, am I audible?
Yes, you're audible.
Okay. Good morning, everyone. My name is Katha Chaudhary, and today I will be presenting our research on detection model for fake news in Bengali language using SVM and random forest. In an age of digital information, fake news is a growing threat, and this issue is particularly pertinent for non-English languages, including Bangla. Our work focuses on developing an effective machine learning model to detect Bengali fake news from online articles and newspapers. Here's an outline of today's presentation. I will begin with an introduction to the problem of fake news in Bengali language, followed by our objectives. I will then dive into the solution we have developed, discuss related work, and explain our methodology and dataset. I will also present the results of our analysis and conclude with the future directions for this project. Bengali fake news refers to false news disseminated across various platforms, both online and offline. It is a growing concern because many people in Bangladesh are vulnerable to believing in false reports, particularly those spread through social media and online articles. It has significant societal impacts, includes creating confusion, influence on public opinion, social polarization, damage to reputation, economic consequences, threats to democracy, and personal harm. Our model aims to tackle this by detecting text-based fake news, which often serves as propaganda or misinformation that disrupts daily life or seeks personal gain. Our main objective behind this work was to increase the accuracy of the dataset without oversampling the dataset and develop practical and effective solution for detecting Bengali fake news. We aim to create techniques that are specifically tailored to the unique linguistic features of the Bengali language. Additionally, we have fine-tuned machine learning models to improve the accuracy of fake news prediction. Several related studies have been conducted in the field of Bengali fake news detection. Here we compare our work to existing approaches that used various machine learning models, such as SVM, random forest, and net bias. As shown in the table, their accuracy and F1 scores vary. Our goal is to outperform this existing model by optimizing our methods. This diagram illustrates the workflow of our work, and this is the methodology we followed. At first, we preprocessed our dataset, then we encoded the Bangla dataset using Charded. We had two different datasets named authentic and fake. We marked this dataset, and then we selected all the relevant attributes and dropped all the null values. After that, we used level encoder and split the dataset into 70-30 train-test ratio. We later use a stratified k-fold cross-validation on 70% trained data and then validate our data with the best model. And at last, generated classification report. Here is a little summary of our dataset. Here is 10 attributes in our dataset named article ID, domain, date, etc. We used all the features excluding article ID and date only. Here is a little in our dataset, we have in total 7,221 authentic data and 1,302 fake data. After splitting for train, authentic and fake data ratio is 5,055 to 911, and for test, authentic and fake data ratio is 2,166 to 391. Before training our model, we had to address several issues with the raw data, such as irrelevant characters, numeric patterns, and encoding errors. We already said that we encoded Bengali dataset using Charded. At first, we import Charded to text like Pradhan Mantri Upadeshta Salmanik Rahmanet Visa Patil that transferred the text into such kind of format. And then we use level encoder to transfer this format into numeric patterns so that the machine can understand the data. Support vector machine, or ISBM, is one of the most popular supervised machine learning algorithms, which is used for classification as well as regression problems. The goal of ISBM algorithm is to find an optimal boundary, which is called as decision boundary or hyperplane, to separate the classes of data points by maximizing the margin. ISBM chooses the extreme vectors that help in creating the hyperplane. These extreme cases are called as support vectors, and hence this algorithm is termed as support vector machine. Classifies new data points by determining which side of the hyperplane they fall on. It can handle both linearly separable and non-linearly separable data through the use of kernel tree. Random forest is also a popular machine learning algorithm and also can use for classification as well as regression problems. It is based on the concepts of ensemble learning, and it combines the power of multiple decision trees to make accurate predictions. It works by creating an ensembles of decision trees, each tree trained on random subsets of data and using random subsets of features. The predictions from all the trees are then combined to make a final prediction, and this approach enables random forests to handle complex relationships, reduce overfitting, and provide robust predictions. To optimize our model, we tuned several hyperparameters. For random forest, we adjusted parameters such as number of trees, depth, and splitting criteria. And for SBM, we tuned parameters like gamma and the optimizer to improve the model's performance. Confusion matrix. The confusion matrix is a matrix which is used to determine the performance of the classification models for a given set of test data. It can only be determined if the two values for test data are known. The matrix itself can be easily understood, but the related terminologies may be confusing, and hence this matrix termed as confusion matrix. In this confusion matrix, we can see the prediction overview for SBM and random forest model. For SBM, true negative count is 140, true positive count is 1007, false positive count is 4, and false negative count is 38. And for random forest, true negative count is 146, true positive count is 1011, and rest false positive and false negative counts are respectively 0 and 32. This graph represents our classification reports of F1, precision recall, and MCC of each model. And here is the accuracy comparison for both random forest and SBM model. Our models were also compared with previous research in terms of accuracy and F1 scores. Our random forest model achieved the highest results, outperforming several existing approaches. This demonstrates the effectiveness of our methodology and preprocessing techniques. In conclusion, our models provide a significant improvement in the field of Bengali fake news detection. With an accuracy rate of 97.2%, our random forest model sets a new benchmark for this task. Going forward, we aim to enhance the model by incorporating new features and testing it on a larger and more diverse dataset. Here we attested some of the references and the are mentioned in the paper. Thank you for your attention, and I look forward to any questions you might have.
Thank you, Kato. I'm just merging my two of the queries together. Number one, that don't you think that your authentic and fake data ratio is very close? And what are the parameters to choose that ratio for this research?
Sorry, you can please repeat the questions once more time.
Okay. My query is, don't you think that the authentication and fake data ratio is very close? Number one. And
Yes.
what are the parameters to keep that ratio for your research? What is your thinking to keep that ratio for research?
Okay. I already said that in our data set, we have 10 attributes named article ID, domain, date, category, source, relation, headline, content, label, and F type. In our data set, we labeled every attributes of this, and our model works on each and every features, like from which source the data news is coming, and which type of the news is this, and the headline, and combined all of this to make a final decision.
Okay, so that you want to say that who is the best to select that ratio for this research?
Sorry.
Hello, am I audible?
Yes, can you repeat the question again?
The first one question, or you after your
The
reply?
second question.
The second question was that what parameters or what was your thinking to keep that ratio for your research? Hello. Are you comfortable with that question, or should I make it in another form?
Please make it in another form.
Okay, so exactly as you said that there are that 10 points to better your fake news and authentic news in Bangladesh. So
Yes.
my question is, whatever the ratio you decided for this, or whatever the ratio from your collection, data collection.
Okay. I got it. I split the data set into 70-30 ratio, and it's give me the best results.
So what was the idea behind to keep that 70-30 ratio?
We tested
That
in
was
many way. We tested it in many way, dividing by 60-40 and 80-20, and then we examine that 70-30 give us the best results.
Giving the more close results to your.
Yes.
Good. Okay, thank you. Any other question, please?
Yes, I have one question, sir. Kotha Chaudhary, I'm very happy to see that you are from Bangladesh also. I'm also from Bangladesh. So my question is, you are basically using two models like SBN and random forest. So do you think that other model can also use to identify the fake news, Bangla fake news or something like that?
Yes, other models also can use in this case, but these two models are these two models give us the best results according these data set and these circumstances, we can say.
So do you think that this is very applicable for income in terms of Bangladesh, because Bangla news are very too much fake news are available in all the newspapers and the portal?
Yes, we can implement this in our country, and it's mainly focuses on Bengali languages.
Okay, fine. So do you have any kind of any other NLP for identify this fake news?
Actually, previously I used other models also, but at last I selected these two because these two give us the best results, and these two are previously also used in many other.
For example, I am basically I want to know the sentimental issues. Sentimental issues are applicable for this kind of fake news?
No, sentimental issues are not applicable. We can work on this in future.
Okay. Okay, so thank you for your presentation. Thank you.
Thank you.
Thank you so much. Yeah, moving
you.
on to the next presentation, we have Thomas Hane with the paper title Evolutionary Bayesian and Quasi-Monte Carlo Hyperparameter Tuning. So Thomas, if you're here, you can start with your presentation.
Yes, we are here.
Yeah.
So, 1 second.
Thank you for the opportunity to be part of the Third World Conference on Information Systems for Business Management. I'm Caterina Montalbano, and together with Matt Molina, we'll be presenting our work on evolutionary Bayesian and quasi-Monte Carlo hyperparameter tuning. While our co-authors, Rolf Domberger and Thomas Hane, couldn't be with us today, we'd like to acknowledge and thank them for their valuable contribution to this work. In machine learning, models rely on two types of parameters to make the predictions: the internal parameters such as weights, which are learned during training, and the external parameters, hyperparameters, which are set before the training begins. And choosing the right set of hyperparameters is crucial for the model's performance, but it's not an easy task. Often we resort to default hyperparameter values, which can negatively impact both the model's accuracy and its convergence speed. And this is where hyperparameter tuning comes in. It's a process that systematically searches the hyperparameter space to find the best combination for a given model. And the goal is a balance between exploration and exploitation in order to improve the model's effectiveness, enhancing both the model's performance and training efficiency. In hyperparameter tuning, exploration is about broadly searching the hyperparameter space to discover new regions that may contain the ideal settings, while exploration, on the other hand, involves refining and optimizing the values within the promising regions, using insights gained from exploration to focus on configurations that show potential for improved performance. And balancing both is key to find the best hyperparameters efficiently, as too much exploration might waste resources on unproductive areas, while too much exploration may overlook better options. In hyperparameter tuning, there are several key methods used to search for the optimal hyperparameter set. Grid and random search are straightforward approaches. Grid search tests all possible combinations of hyperparameters, while random search samples random combinations from the space. And both are easy to implement, but they explore the space randomly without focusing on promising areas, and they struggle when the hyperparameter space is large. Bayesian optimization is a more sophisticated approach. It uses a probabilistic model to predict which hyperparameter set will perform best, suggesting the most optimal set after each iteration based on an objective function. And a common method for this is the three-Panzer estimator. Evolutionary algorithms take inspiration from natural selection, evolving solutions over time by using mutation, crossover, and selection processes. These methods, like the NSGA-Q, a popular genetic algorithm, refine solutions over generations to improve performance. And finally, the Quasi-Monte Carlo method uses low discrepancy sequences to systematically and evenly sample the hyperparameter space, ensuring that all regions are covered equally, which helps avoid missing potential optimal settings. And each method has its strengths, and it's suited to different types of problems depending on the complexity of the hyperparameter space. To illustrate this further, my colleague Mark Molina will now present the experiments we've conducted, comparing these methods on a given dataset and problem, and discussing the performance outcomes.
Yes, thank you, Katerina. So the main objective here was to be able to benchmark all of these different hyperparameter tuning methods that Katerina has just explained. So for this, we chosen a medical tabular data set with a lot of unique responses, more than 166, these behavioral risk factor surveillance systems, so to basically monitor the diabetes with some other important clinical feature variables, both categorical and numerical. We applied some specific preprocessing here, and the data had three main classes. So basically we employed a model, in this case an XGBoost model, to train on a multi-class classification problems with no diabetes, prediabetes, and diabetes. And then as I said, the main goal was to see which hyperparameter set was capable of obtaining a better accuracy, recall, and F1 score as a whole. So what we've employed is we have all of these hyperparameters that are important in XGBoost, and we set a minimum and a maximum, as we can see in this table. So after employing and implementing all of this, what we tested is every hyperparameter tuning methods with 30 iterations. So this means that 30 models were trained so that we were able to sample the hyperparameter space with the proposed method. And for baseline purposes, we also employed random search. So the main results are presented here. So TPE is the three-Panzer estimator, the Bayesian methods, And then NSGA 2 and 3 are the evolutionary methods. Then Quasi-Monte Carlo are a more intelligent way of doing random search. And then we have this baseline as random search. And the first thing we can actually see is that there is no simple answer that all the different methods are getting. So actually they are reflecting the Pareto line very well. So there's not an ideal set of hyperparameters. There are several of them. So then we have to do some kind of threshold. But if we look into the actual results, we see how the tree-Panzer estimator gets the, so the Bayesian methods gets the best accuracy, recall, and F1 score, with an F1 score quite similar to the Quasi-Monte Carlo methods. However, we can see that the time consumed to reach and do all of these 30 iterations is much longer, so almost 3 times the time spent for the other methods, showing that this might be computationally intensive. And then following the Bayesian methods, we see how the Quasi-Monte Carlo methods are in the second positions, and then we have random search and the evolutionary algorithms. So once we have performed all of this benchmark, what we can do is to employ feature importance algorithms so that we detect which hyperparameter was the most important. And actually we can see here an actual agreement across all the methods that basically column sample by tree is the most important hyperparameter that is going to affect the final performance of the model. And then in second, third, and fourth position, it's number estimator, maximum depth, learning rate, and then there are some difference here in terms of the hyperparameter tuning method that we employ. Then it's also very insightful to try to look for hyperparameter interdependencies, because let's say, yes, we want to fine-tune this column sample by tree, this most important parameter, but we want to know what's the value that we have to add and how are the other values of the hyperparameters that we need to set up. So for example, in this case, we have the contour plots where basically each black dot means that this is a sampled space, and we can see here these contour plots for the tree-Panzer estimator, the Bayesian method, and we see how for a higher number of column sample by tree, it is preferred for all number of estimators, showing this top right area that is preferred, and it has been actually oversampled, as the method found that this was the one getting the best results. And again, we can see the same for the different parameters, with the exception of learning rate and maximum depth, where we can see more or less a linear increase or correlation on the actual value. So then if we increase learning rate, we have to increase the maximum depth as well. So another key thing that we wanted to study was the exploitation-exploration trade-off. So basically there are some methods that are going to be more prone to exploit an already known good solution and then try to refine it further. And then there are other methods that are going to be more exploration-like, and they are going to focus not in improving known solution, but in trying to sample different ones and then try to search the best one that has been found. So in this case, we have in this purple color the tree-Panzer estimator, the Bayesian method, and we always can see in all the plots for all the different hyperparameters that there is a clear area where the method has oversampled, so that it's trying to refine the actual hyperparameter set values. And so this might highlight that the tree-Panzer estimator is much more exploitation-like algorithm. And conversely, we can see how the Quasi-Monte Carlo methods are always very smooth, and they try to sample all of the different values in an intelligent way. and actually even more than the random sampler, because it uses these low discrepancy sequences that enable to intelligently and not repetitively sample the same hyperparameter value twice. And so basically, in essence, the quasi-Monte Carlo methods are basically very exploration prone algorithms. And then we see for the both evolutionary based algorithms, these bluish lines, violent plots, we see that they have a kind of a trade-off between exploitation and exploration. So in conclusion, we have studied various optimization method families for this multi-class classification problem, and we found these variation methods are the best. However, they can be computationally intensive, so there's might be some future work here on trying to improve the feasibility of application of this kind of methods. Then we have the quasi-Monte Carlo, which are able to reach a balanced search space. And then we have the evolutionary algorithms, which offer a compromise between exploration and exploitation. So there are some study limitations that we want to address. Is that the specific dataset problem? We want to use a lot more datasets and see if the same conclusions can be drawn. And then we also could improve the amount of optimization methods for each family and the number of iterations, of course. So that's been all. I hope you liked it, and we are very glad to have this opportunity to present in ISBM. And yeah, if there's any question, just ask me. We are here. Thank you.
Thank you, Krishna and Thomas. Any question from the audience? Okay, so thank you for the presentation, and all the best to you. And over to you, Anish.
Thank you.
Thank you so much for the presentation. Moving on to the last presentation of the session. We have Anuradha Desai with the paper title Transfer Learning Approach for Breast Mass Classification on Ultrasound Imaging. Ma'am Anuradha, you may please start with your presentation.
Okay, ma'am. A very good morning, everyone. Am I audible, ma'am?
Yes, you are audible.
Okay. My topic is neural network pairs early diagnosis of breast mass classification system. It's basically a classification problem. A benign and malignant masses has been classified in my work. Okay. In my research work, I have been using the data set in which there are the two types of classes, which is the benign and the malignant. And I'm using an transfer learning approach in which the base model that have been selected is an inception V3, where I'm working on the improving the accuracy in my work. So basically, it's a classification problem where the inception V3 pretrained base model has been used, and that particular transfer learning approach in which the weights and everything has been pretrained weights have been loaded, and then adding the few extra layers as a part of my research work and fine tuning that particular layers is the thing that I've been working on, and I've tried to improve the accuracy. So early detection is very important. As we can say that if we detect the cancer has been detected in the early stage, it is not a life-threatening. At least we can do the proper diagnosis on that. So these are the two classes: benign breast masses and the malignant breast masses. Benign lumps are the mostly, which means they are not cancerous, and malignant are the tumors which are cancerous and have irregular borders. So in 2021, there have been 2.3 million women who are diagnosed with breast cancer, and around 685,000 deaths are globally identified. So getting the based model which can detect the cancer early stages is very important for reducing the thing, and can be the diagnosis can be done at the early stages. So these are the papers which I have referred along with my research work, and in which I have studied different algorithms and models have been used for this particular research. So my objective is use the transfer learning approach using the pre-trained model, Inception V3, and I have been loaded the pre-trained base model weights, and have stacked the classification layer at the end, and which will be trained from the scratch. Along with that, I have added 2 or 3 dense layers and max pooling layers, and fine-tuned that particular layers, and have tried to improve the accuracy in my proposed model. So the basic batch normalization in every layer has been used in the pre-trained model, that is Inception V3 only. So these are the two approaches that we can follow. There's feature extraction, in which what we can do, we can add a new classifier layer, and we can fine tune that particular layer. Another fine tuning in which we can do an unfreezing of the top layers. We can unfreeze those layers and fine tune that on this by Scratch, based on our data set. And these are the two ways we can use the transfer learning approach in the research. The one which I have used is by adding the new classifier layer and fine tune that particular layer only. So how the Inception V3 model works? So it is just a deeper network in which different filter size is used, so that it will capture the information, different size information. If the image contains the information on the full image, then the different size filter is used. And if the image has very small information, then the smaller filter will be used. And in this concept, the Inception V3 model works, and it will use the different size filters, and takes the input in all the same input in all the parallel layers. So it will also working on the factor of reducing the parameters, as we are factorizing the convolutions into the smaller numbers, like 5 cross 5 we are dividing into 2 convolutions. So on the basis of that, the Inception V3 works. So this is this original Inception module. This is how the original input has been given into every layer x axis, and then the next convolutions are divided into the sub convolutions, and this is how it will work. So this is the basic Inception module, and we are going to pre-train all the weights from this, and we just modify only the classification. We are just finding only the classification modules in this classification layer in this. So this is my proposed work. What I have done, I have taken the pre-processed the data set, divided into the training and testing part, and then I have loaded the Inception V3. So pre-trained weights have been loaded. After that, I have stacked the classification layer and fine-tuned that particular layers from scratch based on our proposed work and our data set, our classification model, and then have trained and evaluated the model and obtained the desired accuracy. So these are my expected outcomes. The sensitivity I have calculated, specificity, training, testing, accuracy, confusion matrix, ROC, and AUC curves. These are my expected outcome. I'm able to achieve the accuracy of training accuracy of 99, and testing accuracy, the accuracy that I've achieved is 92. So these are my confusion matrix, in which 135 is the true positive rate that I've achieved in both the cases, and this is the ROC AUC curve that I have achieved. So this is the data set which I have used, in which there are the two types of classes, benign and malignant. To balance the data set, I have used the concept of balancing it, and have normalized the data set into the equal part. So this is how concluding my research, in which I have used transfer learning approach, where the base model which I have used is Inception V3 for the classification of the ultrasound pictures, and have added a classification layer at the top and fine-tuned it and obtained the desired accuracy. Thank you. Any questions?
you, Ms. Nugala. Despite really, I was so I don't have any question. But if there was over.
Okay, sir.
Okay, so
Do
thank
we
you so
have
much
any
for the
question from the
presentation.
participants?
Yeah, please.
Yeah, thank you, Anuradha. All the best.
Thank you, sir.
Okay, so with that, we have come to an end of the session. And I sincerely thank all our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for you all. We, on behalf of the whole team, thank you for the support during this third version of the conference and all the previous two versions. We'll be happy to have you in the fourth version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. And further, all the papers have already forwarded to the Springer. The publication will be live within 6 months, so kindly cooperate with the team of ISBM 2024. I'd also like to thank our session chair for chairing this session. And here is a small token of appreciation on behalf of the team, Global Knowledge Research Foundation, and partners. Thank you so much for your valuable presence, sir. Would you like to give an closing remarks to all the participants?
Yeah. So, in the closing remark, I would like to let we have total papers in this, and papers from different dimensions of different sectors. Work is going right. So, I would like to suggest for there is a lot of so as I thank to give me this opportunity to thank you very much.
I guess there's some technical glitch that we couldn't hear you clearly. But okay, no worries. Thank you so much for your presence, sir. And at the end, I just request you all to please switch on your cameras for a quick snapshot of the virtual conference. Okay, thank you so much, everyone. Have a great day ahead. Thank you. See you all soon.
Thank you, everyone.